Welcome to Ask and Learn.
Was to figure out how many weighings will we need to do to ensure we find a counterfeit coin if we have that one is lighter than the other ones. So let's first talk about how many weighings we possibly could do. So they talk about this in the chapter. So what we can do is, so we can think about it this way. Well, we'd end up having 12 different results because we can either have the coin lighter and be the fake, or each of them. So that would be 12 outcomes. And then we will have 3 decisions essentially to make. So we can either have where 2 coins, one coin is less than the other, the coins are equal, or one coin is greater than the other. So we can have that. So to approximate how many decisions we would need, we would do log base of the decisions, 3, of the outcomes, 12. And so then this is something around 2.26, and then we would just take the ceiling function of this to say 3. So 3 to ensure. So you could do something like you just pick 2, throw them down and see if one's lighter than the other, and you could get it in 1. But this here ensures that we can create some algorithm that after 3 weighings, we will get to figuring out which one is our lightest. All right, so let's go ahead and start. So the first thing I would do is I would just throw 6 in each side and figure out which one is going to be lighter. So I'm just going to throw 1 to 6 over here, and then 7, 8, 9, 10, 11, and 12 over here. Okay, so this is our balance. Well, let's say we go to the left. So it tips down to the left, so that means the left side's heavier. So we have 1, 2, 3, 4, 5, 6 is heavier. So that's what we're going to do over here on this branch. All right, well, after we do this, then that means this implies that 7, 8, 9, 10, 11, or 12 has the fake. Since it would be the lighter side. Okay, now let's do that same thing with these. So we'll take 7, 8, 9, and then 10, 11, 12. And so again, let's say the left side has where this is going to be greater than the other. So then this implies that either 10, 11, or 12 is the fake. So now what we can do is just compare the first two. So we have 10, 11. And if 10 is larger than 11, then that means 11 is our fake, since that's going to be the lightest one out of all of them. Because remember, we're assuming that all 11 of these coins weigh the same, except for 1. We have the case, now this is where our third decision of it being equals come in. So if 10 is equal to 11, then this means 12 is our fake. And then lastly, if 11 is larger than 10, then this is going to be our, or 10 is going to be our fake. So you can see this is pretty much the algorithm you would do. So you would start with the 6 on 6, put them in, see which one is lighter. Then you're going to go ahead and then split the lighter of those again into 3, see which side is lighter, then go ahead and compare that with the next one, and then say, okay, well, I take 2 of these since I have 3. Which one of these 3 does it fall into here? Is one of the coins lighter than the other? If one of the coins is lighter, that's our fake. If one of the coins is equal, then the third one you didn't weigh is fake. So let's actually write that out, and then after that we'll fill this whole tree out. So if you don't want to see the whole tree, you won't have to, but I'll just go ahead and write that. So our algorithm seems to be, so split coins into two groups of 6. All right. So then the lighter group split into 2 groups of 3 and compare again. Now this lighter group compare any of the 2, so actually now this lighter group of 3 coins, just to be a little bit more specific, compare any of the 2 coins. Now if one is lighter than the others, then that is the fake, or maybe we should say the lighter. Then the lighter one is the fake. If, though, both are equal, then the third we didn't weigh is our lightest. So I'm sure you could type this up into a more computer sciencey looking thing, but I feel, at least for the purposes of this chapter, this is good enough for at least what they're expecting for the algorithm. So yeah, if you just want the algorithm, then that's all you really needed, and also is that the minimal was 3. All right. But so for the rest of y'all that want to see this tree actually get finished, completed, which is essentially the whole thing we're doing in this chapter, the idea is trying to teach uses of these tree expansions. We'll go ahead and finish this. All right. So now let's start over here. So now we're going to assume instead that 10, 11, 12 is larger. So now we're just going to do that same thing. So we're going to compare 7, 8, 9. So we'd have 7, 8, and then again we have 3 choices here. So we can either have where 7 is greater than 8, which then means 8 is the fake, or we can have 7 equal to 8, which means 9 is our fake, or we can have 7 less than 8, which means 7 is our fake. All right, so we have those. So that was all the possibilities of the left side. And you can see that, so if we have 1 weighing here, 2 weighings here, and then we have our 3rd weighing there. So it seems like it still matches up. Now let's do the other way. So now we're going to say 7, 8, 9, 10, 11, 12 is larger. So then we're going to split the lighter group into 3. So we have 1, 2, 3, 4, 5, 6. And now, again, we're going to have 2 different cases. So we can have where 1, 2, 3 is the larger side. And if this is the case, then remember we weigh any of the 2 coins. So I'll just do 4 and 5. And so we then have 4 larger than 5, which is going to mean that 5 is the fake. We can have 4 is equal to 5, which means 6 is the fake. And then we can have 4 less than 5, which means 7, or not 7, 4. I don't know where I got 7 from, is the fake. All right. Then over here, we can have 4, 5, 6 being larger. So then that means we want to compare 1 and 2, or at least 2 of the coins from that pile there. And then we have the case of 1 being larger than 2. So that means 2 is our fake. We have 1 is equal to 2, which means 3 is our fake. And then we have 1 is less than 2, which means 1 is our fake. And you can look down here, we get to the case of each of these being the fake. So we get all the possible outcomes. And then you can see in each of these cases, we only ever have 3 weighings.